In this video, we're going to be learning about laws of refraction. Now, refraction means that light undergoes bending when it travels from one medium to another medium. So, to understand better, we have two mediums surface interface between us, medium 1 on top, medium 2 down, and we have a laser light as well. And I'll also freeze it to our front view. Now, you see, we have our laser freely available for us to move, and it is undergoing certain set of refraction. Let's discuss this more. Now, we see the laser is traveling from air to glass. That means our rarer medium is on top and a denser medium is down. So when light travels from rarer to denser medium, it bends towards the normal. What does it mean? So when the light coming out from the laser light, we call this as the incident ray. Now, the point where the incident ray strikes the surface or the interface between the two mediums, that point is called as the point of incidence. And now this is where we drop a normal on top and down. A normal is nothing but a 90-degree line drawn at that interface. Now you see, our angle of incidence is nothing but the angle between the incident ray and the normal, which is measured to be currently at 45.64. We can see that in the output as well. Now, if we take a closer look at our refracted ray, that is the ray that is bending inside the denser medium. Now, in absence of this glass, this light would have traveled perfectly straight, right? But since glass is there, it's undergoing a bending. Now, you see the bending is towards the normal, and this is where the normal is, and that's why we say it bends towards the normal. Next, we'll also observe that the angle between the normal and the refracted ray is 28.49, whereas the angle of incidence is 45.64, which is greater than the angle of refraction. So this is again bending into a denser medium. Light bends towards the normal. Now what happens if I reverse it? What if I take the laser down? Exactly right, if you guessed it. It will bend away from the normal. So you see, this becomes our incident ray. Our point of incidence is still the same. And in absence of the change in medium, the ray would have traveled perfectly straight. Now since the normal is here, it is bending away from the normal. So you will see our angle of refraction is greater than the angle of incidence. Now, further, you'll also see a phenomena where if we increase our angle of incidence more and more, at one point, there is a place where the light, the refracted ray, will graze the surface of the two medium. Now, this is an important angle. This angle is called as the critical angle. The reason being is, it's so critical is that if we increase the angle of incidence beyond this, the light will no longer undergo refraction. It will undergo reflection, and not just any reflection, undergoes total reflection. And because it travels back into the same medium, so you see it's traveling from glass into glass, we call it as internal reflection. And together, we call it as total internal reflection. And for this to happen, there are two conditions that has to be satisfied. Light has to travel from denser medium to rarer medium, and the angle of incidence should be greater than the critical angle. If these two conditions are satisfied, we will see a total internal reflection taking place. Also, we can further change the mediums with us and see what happens. Now see, we know that light is traveling from glass to air. What if it was traveling from glass to glass? No refraction takes place. It's traveling in the same medium, right? So no refraction would take place. But if it travels from glass to vacuum, refraction will take place.